Okay, I'm ready. Sorry for the delay. So this talk has been retitled DBIx class light bulbs. So this should answer all the random questions or issues that you run into when you're learning DBIx class. How many of you have already used or played with DBIx class? All right, good. All right, good. So you should have a pretty good understanding of how to generally interact with DBIC in this talk. So yeah. Okay, we're sort of hiring at my company. So if you're okay with moving to Dallas and you want to work with DBIx class and Catalyst and lots of other cool stuff, talk to me. That's me. Okay, so let's take care of some basics, and I'm here for you to help you understand them. So a schema is just a bunch of tables, or for the pedants in the room, views, but that's much less common. A result is a row, and that's anything you get out of a query, and we'll go into more depth in all these things. A result set, which, well, a result set is a query, and this is super important. It's not, it's an in-memory query. It's before you've actually hit the database. And again, we're going to go into more depth with this, but basically just keep in mind that a result set, it's just like a query plan. You haven't hit the database yet. You haven't even prepared the actual SQL. It hasn't been done yet. ResultSource, this is less common for you to have to know about, but I just want you to have it in the back of your minds. ResultSource is a table, or again, view, and that's what you generate the metadata for your result on. And then last, there's the storage, which is just your actual database. And you could theoretically share this across multiple schemata if, for example, you had two schemas that were connected to one that were both in one database, but I've never seen that before. All right. Does anybody have questions? Because you need to understand this. All right. So definition by a schema loader. I think this is the lazier way, but it's pretty common. And Larry Wall said lazy is a virtue for programmers. So I'll go into this briefly. So if you want to define your schema with schema loader, well, that's a little big, sorry. If you want to define your schema with schema loader, the first thing you do is you create your database with DDL or some tool, some GUI. So for me, that would be SQL Server Management Studio, or whatever. You can use anything. And then you generate your actual schema from that. This is a little snippet of code, and all these slides will be on the internet after this, so you can copy paste from it or whatever. But this is just a little snippet. I think it's at the top of the pod for schema loader, and this will actually put the schema that you could have written yourself in this folder based on what it connected to. Now, there's some tips. First, it really helps if you name your tables and your columns consistently. If you don't, sometimes it can get confused, especially when it comes to single and multiple things. You have to create foreign keys. If you don't create foreign keys, it can't figure out what your relationships are. That makes sense if you think about it, but you really need foreign keys if you don't want to write your schema by hand. This is a link. I probably don't have internet right now. Yeah, I don't. This is a link to a little shell function I wrote that basically you can pass it the name of a table and the schema loader version number that you want to use, and it'll tell you, hey, this is what I would have called that result set. So for example, newer versions of schema loader are better at when you say, for example, you have a people table, and it'll change that to the person result set. So this is a really handy thing to not be surprised. And again, I would recommend you go get the slides after this. So that's really it for schema loader. I only use it during migrations, so pulling it out of the database. Are there any brief questions for that? Because I can't answer a lot. All right. Okay, definition via Perl. This is the way I like to do it. I think defining it with Perl gives you a lot more flexibility. So for one, you have the schema. This, again, represents the database. it's good to put like high-level methods in the schema. So you might have a method that touches 3 or 4 tables. Makes sense to put it in the schema versus result or result set. There's almost nothing in the default schema. So this is it. You're going to want to put a version number for deployment later. And then this load namespaces call basically tells the schema that when it first loads up, it wants to look in a certain folder to pull out its results, and then also make a default result set base class for all of your result sets, which we'll go into in a second. But I just recommend this wholesale. Unless you know what you're doing, this is the way you want to define your schema class. Okay, so for the result, again, represents a row. This is where most of the configuration for your schema is going to be. I'll explain that more later. And then I'm going to use Candy. Some people think it's really important. I don't, but I wrote it. But it really helps for these slides because it makes them shorter. And if you've used DBIC before, you will notice. So to define the result base class, this is not super important, but it's a good idea. If you have a base class for your results and later on you want to add some rule to all of your results, you can do that if you have a base class. So for example, for us, we decided that we didn't want cascading on any of our relationships. And when you have a base class, that's trivial. It's one override. So this is what I used for the slides, basically. You define your package. You set a base class of DBIx class core, which gives you all the various methods on your results. And then I added this component called relationship dwim. And what that does is, well, I'll point it out when we get to it. All right, so Candy base class. Again, this is really not required, but it really helps with the slides. So all we've done here is we've defined a class, and we're inheriting from the default Candy. We set the base to my schema result, and what that does is when you use this, it sets that base as the base class of the class using it. That'll be more obvious when you see it. It also sets the Perl version to 20. So for example, if you import this, you will get all the features of 520 enabled. And then AutoTable automatically generates a table name based on your package name, which is pretty handy and again, very good for slides. So here's the result class. So the first thing we do is use Candy, and that has set strict, set warnings, set it to use Perl 520, and it's defined a table. And then also you'll notice that there's no __ package __ arrow for all these calls. And then there's a little bit of sugar of, for example, primary column adds the column ID and then also sets it as the primary key. Aside from that, this is a 100% pass through. It doesn't do any actual work. Whoops. So, and then the other thing that I wanted to point out before we go into depth is the fact that I didn't have to type the full schema there. That's from that relationship dwim helper that I showed you earlier. Now, really, all we're doing here is, again, this sets the table. All of these column calls add columns to the metadata and thus add accessors for all of these. And then we have the relationships, which I'll go into in just a second. And then finally, I add a unique constraint based on the name and the type. This is almost exactly one of the result classes from our schema at work. Okay, so relationships are a thing that people tend to get confused about, so let's talk about those. So belongs to, this is the only thing that a foreign key actually has anything to do with. The artist ID on the album points to the artist ID. The album belongs to the artist. So if we could trust databases, and we could trust all you guys not to get anything wrong, this would be a non-undef accessor. But because users lie and say, hey, this is non-nullable or whatever, and databases are buggy, we can't really do that. And this is Perl anyway, so it's not like we have a type system, or rather a static one. Either way, you should be able to depend on a belongs to be there. Now, has many, it's the other side of the belongs to. So the artist ID points to the album.artist ID. Obviously, all of you being SQL experts know that you can do that. So the artist has many albums. And that is an accessor that gives you a result set, which we'll go into more depth later. But the thing you have to realize is when you call a belongs to, you get an actual row that gets pulled out of the database that has everything you need to interact with that. On the other hand, a has many gives you a result set. And you can do queries on that, but until you actually realize that by, we'll talk about how to do that later, you don't actually have any data yet. Again, it's just a query plan. Now, are there any questions? Because you have to get this. All right, good. So there's a few other relationships that are more rare. There's a might have. It works the same way as the has many. So for example, artist.id has a previous name. I had to kind of come up with examples for this because in our schema we have like maybe 4 might haves and they're just bizarre. So it's 0 or 1, that's it. And then so an artist might have a previous name. This is the example I came up with. Some band. It's a good band. You should listen to them. So this would be an undefable accessor. It gives you a row back, not a result set. But it could return undef. And again, well, I'll keep going. So has one is the same as might have, except it only returns 1 row. Again, this is pretty rare. So this is just a really weird example, but like an artist might have a first album relationship. I don't know why you would do that, but you could. In fact, that's like exactly the use case we've used it in, it's where we have like a big list of things and then we say, hey, here's one of them. Go ahead. Okay, I thought you had a question. So the artist has 1 first album. Now, so this should be a non-undef accessor, but again, because users lie and databases have bugs, we can't really trust that. In fact, when I was making my slides, I grepped for all the has ones in our database. And we have a few has ones that should be might haves because they're not insured. It's a hassle. Okay, and then lastly, many to many is not really a relationship. So we'll get into that now. It's not a relationship because it crosses more than 1 layer of joins. Now, I can't really speak to why that's the way it is. Matt Trout, in his eternal wisdom, decided that a relationship is 1 join. And that's worked well for us. So many-to-many is not a true relationship. It only adds methods to the result. So when you use many-to-many, you get a method from, for example, let's say you have artists and like what genres they are. You might have a join table between. You can't join or search on that many-to-many. You'll have to go through 2 levels of relationships. And we'll go into that there. But the thing you have to realize is many-to-many is not a real relationship, and it will be a hassle when you run into it. So I know that's pretty small. I wonder if I can scroll left and right. I can't. All right. I know that's pretty small, but the idea is the artist goes to the artist label table, and then the artist label table goes to the label table. That's fun to say. So basically the idea is you've got your label and your artist, and there's many of both, and they join together. Whoops. All right. So the artist many-to-many tables. It doesn't work as well as the other ones. So it's just sugar. That's really all it is sugar. Okay, and then again, I mentioned the result source. This represents the table. It was totally a side effect of the result definition that we had before. So when you define the result source just happens. Or on the other hand, you might say you define the result source and we made a result for you. Again, you don't really need to think about this, but it's handy to know about in a pinch when you need to look at the metadata for your results. Okay, so when you define your result sets, just like with the result, it's a good idea to make a base class. So this is a typical base class. Just like with the result, we load a couple components. One of them that I recommend everyone load is ignore want array. This can bite you really bad when you're using DBIC in a functional manner. So you have a result set, you call search on it, you pass it to a function, whoops, you just selected the whole database. Because search in array context, or list context rather, gives you, it actually pulls in everything from the database. So this turns that off. So it always gives you a result set when you call search, and if you actually want to get the values out, you have to call all. And then ResultSet me, it's just a real short, cute thing and helps with slides to fit stuff on the slides. So, oh, sorry that's so wide. So here is an example of a ResultSet class. Now, note that our package is my schema ResultSet device. That is automatically the result set of the device result. So when you go to your schema and you go to pull out some devices, you have all these methods at your fingertips. So for example, I've added a search by name method that just, you can call it by passing a name to search by name. And really, because it's DBIC, you could pass an array ref and it would do ORs, etc. But that's not important. The real issue here is that you have this method in the result set for devices. I've used me here to ensure that you have the right prefix in your search. So if you've used result sets before and defined result sets before, you might have heard of the current source alias. Me is just sugar for current source alias with a dot at the end, so you don't have to do some weird quoting. You really, really, really have to put the current source alias, or just use me because it's a little bit shorter, in your result set methods. Because otherwise, at some point, you're going to use that result set method after doing a long relationship traversal, which again, we'll get into. And it's just going to explode because you're going to just say name, and 3 tables will have names, and your database isn't going to know which one to search on. Or, I don't know, maybe in MySQL it just picks one at random. That would be awesome. Well, okay, good. All right, as it should. All right, so result set usage. This is important. Result sets are, they're what make DBIC awesome. So they're like your entry API into DBIC. So, excuse me. So when you use a result set, that's how you first start getting rows out and interacting with the database. Again, it's super powerful. It's important. So searching. This slide would be maybe better titled chaining. So we're going to go into chaining a little bit here. So this is pretty basic. We're just printing out the name for every row in the device table. Here, I'm going to zoom that in. For every row in the device table where me.name is phone. That's it. There's nothing really special here. And like we talked about earlier, because it's the device table, we have this cute little method so we can just say search by name phone, which for what it's worth, that's especially handy when you have an older database. Like we have databases where the name column is literally number, like the string number is the column that represents the name of the device. So this gives you a way to kind of paper over those awkward old decisions that you don't have time to fix. So this is kind of cool, nothing special here. What's really cool is that you can do this. We've grabbed our result set of devices, and then we've called the enabled method, which we defined before, and then we've called the search by name method, and then we've called all. So what's happened here is each of these calls gives you a result set that has been winnowed down based on that result set method. Now you don't have to use those methods we defined before. You don't have to use these. You could use search. But using these methods, it gives you a human readable API that is testable and nameable. And again, you can deal with poorly named columns, etc. Okay, relationship traversal. We talked about this a little. I've mentioned it a few times. The fundamental methods that you need for relationship traversal are related result set and search related. This was my first light bulb moment in DBIC. And actually also join, which is a search option. So I'm going to show you an example, or I'm going to show you my light bulb moment real quick. Come on, there we go. Okay, so there we go. So part of the issue here is that I was using many-to-manys. So these two relationships are many-to-manys, and that won't work. So you then have to expand those. So in my case, I had to go through role permissions and then grab permissions, then go through permission screens, and then I could just move on. And this is a good example of relationship traversal. So we've gotten all these section objects from the user by going through, what is that, 6 levels of joins? Yeah, 6 levels of joins. Now, there's this weird thing that I mentioned at the end where I had to call distinct on that to deduplicate the actual rows. There might be a way around that if you design your database differently, but I'm not convinced. Anyway, that's just a handy little thing to remember. But basically, this is relationship traversal. It's super handy. It's really important, and it generates more efficient SQL than a I don't know, a less prepared ORM might, because this is just one query. All right, does that make sense to everyone, the relationship traversal? All right, good enough. And then I don't have an example with join, but basically with join, it works the same kind of way, but it's an argument to search. I'll show you a good article I wrote over Christmas that gives you a good feel for the way that join works and related result set works, because you need both for different situations. Okay, subqueries. You really need to know about subqueries to write efficient SQL, and people tend to get this wrong in DBIC all the time, or rather, ORMs in general. So the secret sauce is asQuery. asQuery gives you a data structure that represents the query in a way that you can pass to searches. And I'm not going to go into exactly how that works, but if you just pass a result set to a search, it's just going to explode because it's an object. And you probably also need get column. So the way you'd use the way you do that is, can you guys see that in the back okay? I'll assume that means yes. All right, so the way that works is you've got your ID and you've called in, and then when you grab get column, that creates a result set column object. So you can actually call max, min, average, and other column level operators in SQL on that to actually pull data out. But in this case, we've called asQuery. So this is a subquery where we've grabbed all the computers that have the same ID as this location RS. This is some work code. It's really just a dumb way to do distinct. But that's the general pattern for a subquery. And like I said, you really need to use subqueries for efficient database interactions. Okay, so prefetch versus join. People tend to get confused about what prefetch means and what join means. So join is just for searching. So you might want to say, I want to find all of my friends who know some other friend. So I would do a couple joins there to do that. But if I want to actually pull out what those friends are and the other friend, I could use prefetch. They both look the same. Do I have an example? I don't. They both end up looking the same, but basically, and there's a lot that can go into Prefetch, but Prefetch can actually populate objects when you pull it out in an efficient manner, whereas join, it's just going to add it to the query, but not pull it from the database. So use join when you can. Okay. So columns versus select as. I've never, ever needed select as. Not only is it poorly named, but it has a weird API. You don't need it. I mean, you might need it, but you almost certainly don't. These two things are the same. So you selected foo as bar. You can use columns, bar goes to foo. These are exactly the same. There's only one thing that columns can do that select can't. It's really hard to get columns wrong. Whereas like with select, you could leave off the select part, you could leave off the as part, you could have a different count of, you could have more things on the left side than the right. You can't do that with columns. The only time you need select as is when you have a single query that returns multiple columns. I can never remember the example that I've heard that does that, but there's places where you do a single SQL function and that becomes more than one column. That's when you need select as. Other than that, just use columns. Okay, does that make sense to everybody? All right. Okay. Oh man. Why don't I have wrapping? That's a bummer. Okay. I think. Hold on a second. Man. There we go. Okay, much better. So populate is a handy way to bulk insert into the database. I've actually replaced vanilla DBI code that is a little naive with populate and had it win with respect to speed. Do I have an example of that? I don't. So you should really use populate if you're putting a bunch of stuff in the database. Again, I've found that it beats DBI code unless you just really want to write the painful stuff to get fast insertions. Okay, so remember earlier when I was telling you guys that with a result set, until you actually do something that hits the database, it's just a query plan. I've kind of made a list of the different things that hit the database, both from a result and a result set standpoint. So here are the result set. Here are the result set methods that actually hit the database. You've got all, first, single, next, find, update, delete, and populate. As far as I could think of, and I mostly came up with these on the plane flight down, there's not other result set methods that hit the database. There might be if you did. No, I can. Create. Yeah, create. Yeah, create/insert. That would hit the database to actually put a row in. But this is just a good thing to keep in mind, especially next, which puts an iterator on the result set that then you need to keep in mind exists, because unless you exhaust the iterator, some databases will get confused if you then do something else. At least mine does. And then also what row methods hit the database. You've got update, delete, and then non-has many row accessors. So remember, those other ones actually pull a row out of the database. If you didn't do a prefetch, it's going to hit the database when you use that accessor. And then also discard changes, which is a weird way of saying refresh this row from the database. Those are the four, again, that I could think of that actually touch the database. Okay, my favorite thing to talk about, extensions you're going to need. These are extensions that will save you time and money and make you profit. So deployment, you need to use one of these two options for deployment. Deployment handler is a thing that I wrote a few years ago, and then migration is a tool that John Napierkowski built on top of that. People tend to think migration's easier to use, so fine, use it. But basically, I don't have enough time to go into how this works because that's a whole hour-long talk itself. But it will help you keep your database in a place where you know what your schema is. I know that at my work we have people who use it and people who don't, and the people who don't just modify their database willy-nilly by using the UI. That's a nightmare. Don't do that. Okay, so row extensions. Most of these I wrote. On-column change is a handy helper that will let you trigger other events when a column on a row changes. That's kind of a tough thing to do because DBIC does dirty tracking. You can update with an accessor. You can update by passing in a hash ref to update. This actually lets you wrap your changes in a transaction. So if you want to, like we actually used it for like an MRP system where when someone would decrement one thing, it would decrement it somewhere else, and they didn't actually want those to be the same value necessarily. So anyway, on-column change is a handy thing. It's confusing to people. Doc patch is welcome. I can't figure out how to make it easier to understand. Proxy result set method. I'm gonna, if I have time, go into some details on how to use this. But proxy result set method basically lets you avoid re-implementing logic in your result set and your result class. And if you implement it in your result set, you can do it efficiently everywhere, not the other way around. Similarly, if you have special logic in an update, if you put that logic in your result set, you can then call that special logic from your result. If you do the other way around, when you call update on your result set, either it won't get called at all, or it's going to take forever because it has to call update on every single row. We already talked about relationship DWIM. This is kind of a handy thing that people tend to re-implement all the time. Basically, it will generate a toJSON method in your result based on your metadata. Because it's Perl, you can then subclass that and add columns or remove columns or whatever. But it's a good default. It's a good starter for your toJSON method. Timestamp. This is just a handy way for you to ensure that at creation time or update time, you set the timestamp on a given column. And then also it pulls in something else that actually inflates those columns into datetime objects, so that's handy. This guy over here pointed out last night that I should mention that you got to watch out for those datetime objects because they're references. If you have a row and you modify some of the values in the datetime because Rolski decided that datetime should be mutable, for better or worse, when you mutate those, DBIC doesn't know because the reference hasn't changed. And if the reference hasn't changed, the dirty tracking in DBIC means you will not actually update your datetime. If you want to update your datetime, you either need to use the accessor to pass in a new datetime, or I think Getty has a helper that lets you always update everything and ignore dirty tracking. You just need to be aware of that issue. You should use a DBIC encoded column for storing passwords in the database. Everyone should be hashing their passwords. Encoded column has every option you would ever need for that. I recommend bcrypt. You can tune that up if your server gets faster or whatever. But basically, use encoded column for storing passwords. And there's a newer one. I can't remember. It's passphrase column. You might also want to, here, let me see if I can find that real quick. Yeah, that's it. So passphrase column is a good alternative because it lets you switch your encoding within the column. So for example, for me, I might be already using MD5 and I want to switch to bcrypt. So the users who are MD5, there's already metadata because of the way that passphrase column encodes its columns. So when it pulls it out of the database, it can tell, oh, this is bcrypt, this is MD5, and then you can do another level to re-encode it when they give you the password. All right. Yeah, that's it. So ResultSet extensions. I already mentioned ignore one array. I highly recommend everyone use this if you are starting a new project. For old projects, it will bite you if you start using it because you'll find that you depended on the one array context.
Or just always call search RS instead of search.
Yeah, that's true. You could always call search RS instead of search. That would work too. And then I guess you could get grep for search calls and switch it. Again, we already talked about me. That's just a handy shortcut that makes current source alias shorter to type and remember. This is a weird helper that was contributed by a coworker and a couple other people. Basically, here, let me just show you some docs. Instead of calling search on everything in your result set, you can call these methods. So you could call HRI to get the HRI-based output and then call all on that. You could call limit, you can call group by, etc. Basically, it gives you like a little DSL that's a little bit nicer than passing a big giant hash to a search. So yeah, that's fine. We'll just leave it at that for that. Okay. Result class dwim. You probably don't need it if you use shortcut, but that lets you pass, like, for example, : HRI to the result class in the search. I think it's kind of a handy thing, but if you use shortcut, you probably don't need it. In core, DBIx class doesn't support unions or any of the other set operations. This helper gives you that feature. Again, I feel like everybody needs that, so I would put it in your base class. And then we'll go into correlate relationship if I have time. And then date methods is a handy thing I made recently. It supports MySQL, Postgres, SQLite, Oracle, and Microsoft SQL, and can do portable date comparisons and manipulation in the database. So thanks to Ricardo, I wrote a synopsis of that. So for example, you can do, oh, come on. Why won't you scroll? Anyway, you can generate SQL that will actually group by, for example, in this case, the year and the month, and pull out that year and the month. This is the worst. Okay, anyway, it's pretty cool. You should use it. And then there's one schema extension I would recommend everyone always use. I made this helper called quote names because normally you quote your names with configuration in DBIC, and sometimes configuration gets out of sync, and I've had problems where I forgot to turn on quote names and all of a sudden the tests are failing and I couldn't figure out why, so this forces it always to be on. So you probably don't have a good reason not to quote in DBIC, and if you do, you're doing something else wrong. So you should use this. Okay, I have, what, like 10 more minutes? 9? So I have some extra slides, but I'm going to give you guys a couple minutes for questions if you have any.
A lot of this, frankly, went over my head because I don't have a lot of context. Where should I go to? What should I go read and then watch this again?
Okay, oh man. That is too bad because I meant to solve that problem. I have a couple other talks. Like there's this slide that gives you more features. I don't think it's a great intro. This is where I'll have the slides. You could watch it again. There's supposed to be a new DBIx class walkthrough manual type thing that I think we added with the last version. Let me see if I can point you to that. Is it this guy?
I went through the quick start, I guess, about a year ago, and it was enough to get me going. Until you struggle with it. Yeah.
Yeah.
Right, it's a struggle.
So the DBIx class manual quick start is a good, maybe gentle introduction. There's a couple other manual type things in DBIC that can be helpful. But quick start is probably the one to start with. The mic's not working?
The GitHub mic.
Oh, yeah, that's because I haven't pushed it yet. Well, I clearly have internet, so give me 1 second and I'll push it right now. Any other questions? Oh, come on. Go ahead.
I'm coming to this from the context of rows DB, and I'm not very deep in that yet, but I wonder
Sure.
if you have any exposure to that, if you can contrast.
I really don't. I don't at all. I do know that rows, for better or worse, has a really good They focus on performance at the expense of code clarity sometimes when they wrote the core of rows, but that's really it. When we switched to DBIC, the only reason we did was because it had better SQL Server support. All right, let me push those slides real quick. Okay, so that will take a minute. In the meantime, I'm going to go over some of these other more advanced things. Is that all right? And go ahead.
More of an in-depth question. I've got a situation where there's a lot of one-to-many relationships going down through the database.
Sure.
And so you can use Prefetch to sort of roll those all up into one query.
Right.
But then when I'm down at the many depth, then when you use the belongs to relationship to go back up, it's still recreating all the parents all the way back up.
And it actually does the query, right?
Right.
Right.
Is there any way that I can get it to know that this was created through a has many and automatically know the parent it came from?
You know, I think if you set the cache, you know what? No, I don't think so. I don't think so.
Yeah, because I like I said, mine's pretty deep, and so,
Right.
and then I'm going up and it ends up throwing lots of queries back to my database that I shouldn't have to do because
Right.
I should know the parent.
No, I agree, but
Actually does well.
what'd you say?
It's one thing that actually RosDB does well.
Oh, okay.
To manage those relationships.
Well, there's a big, tall guy with long black hair walking around here called Ribasushi. He might actually have ideas on how to fix that, but that's a core problem. That's not like a usage problem. That would need changes to DBIC, I suspect.
Or an additional help.
You sure the cache doesn't populate?
I think it only works for result sets, and for a belongs to, you don't have a result set. Have you tried turning on the cache?
I haven't played around with much at all yet.
Okay, well, there's a cache attribute on result sets, and you can, for example, clear it every request or something. So that might be a way to fix it. I haven't tried that. But yeah, it's worth a shot if you haven't tried it. Okay, so this article, Set-Based DBIC, I highly recommend those of you who have time read that. This is still pushing, so 91% complete. Anyway, that really gives you a good feel for join versus the other traversal that I showed you guys before. It gives you a good feel for correlation and how to do that and when to use proxy result set method. Yeah, give me just a second. All right, augmented inflation. So is Ether here? I guess not. Ether asked this question in the DBIx class channel about how to have a more custom result class, but not always. And it's actually a super powerful concept. Basically, when you pass a result class to DBIx class, it's not necessarily that class that it uses to inflate to. That class is an inflate. Oh, what's the word? It's a factory. The result class is a factory that gives you other result classes. So for example, in this case, I have a result class that all right, that GitHub thing is pushed. You should be able to get to it. The result class can pre-populate information. So for example, we ran into a problem with a bug in DBIC where we couldn't prefetch something. So with this augmented inflation, I made a little tiny moo object. I added a few different accessors on it that have builders that do a single query each. One of them pulls all of a table from the database. The other one pulls a subset of that. And then in my inflate result method, this is like a nightmare of code, but I just want you guys to realize that it's doable. I populated what should have been prefetched by hand. So instead of doing an n+1, or if prefetch had worked, just a single query, I do 2 queries. Or worse, 3 if I have to do both of these 2 code paths. So I just want to make sure that you guys understand this is a doable thing. It's not the worst thing ever, and it's a really, really powerful option that is at your fingertips. Is that? Oh yeah, and then transactions. So I have this crazy thing that I wrote that I just want to talk about briefly. What was that? I will. Just give me a second. No, that's fine. Okay. Is that big enough? Okay, so the cool thing about this is that if you guys haven't used transactions in depth in databases, or at least in Microsoft SQL I can speak for, and probably Postgres, you can do some really awesome things. So we have licenses in our system, and we need to make sure that people don't accidentally exceed those licenses. So I have this crazy method that takes a couple code references and lets you say, okay, here are the current licenses used, do the action, now check the licenses, and if the licenses are now exceeded, roll back the transaction. And it's the coolest thing ever. Anyway, I want to encourage people to take advantage of that, because the transactions like that they're the best. They're awesome. So I know that this code is pretty messy on the slide, and it's a little wide, and really.
Do you notify the user that their licenses are exceeded? And
yeah.
It's only $1,000 for another one.
We include a phone number in the error message, but we don't give them a cost because it might be more. So that's a handy thing. I throw an exception object, and in the controller I can tell which exception object I got, and then we can give them a localized message. So if you're not already doing that, you really should be, because exception objects are super handy when it comes to user errors. Okay, so how much time do I have left? I think I'm out of time. All right. So this is pushed. These are where the slides are. If you want to write down that URL, now's your chance. Read that set-based DBIC article, and thanks for your time.